In this video, titled Misleading Statistics, I, Cooper Bruick, will be taking you through three types of misleading statistics. The first, the truncation of graphs, the second, selective data gathering, and the third, conditional probabilities. So without further ado, let us jump into the first type of misleading statistics, the truncation of graphs. Truncating graphs refers to when a graph axis has been altered to exaggerate or hide certain features of the graph. For our example, let us look at a graphic provided by AMC's digital library that shows how truncating the axes of graphs can create misleading statistical representations. Graphs A and B examine what would happen if President Bush's tax cuts expired, but paint very different pictures due to the truncation of the y-axis. Graph A is an honest depiction of the graph, as it starts at 0, so the tax cuts are not as big as what graph B tries to exaggerate by starting the graph at 34%. Graphs C and D show how truncating the bar graph can sometimes actually be beneficial. Graph C has such a large scale on the y-axis, it is impossible to see the trend in global temperature over time. By truncating the bar graph and focusing on a smaller portion of the graph, we get a better representation of average global temperature. So be careful when interpreting bar graphs and pay special attention to the scales. Next, we will look at selective data gathering to create misleading statistics. Our example of this will be an ad that reads, quote unquote, 80% of doctors recommend Colgate. What the ad left out was how the data was gathered. This stat leads consumers to believe that 80% of doctors recommend Colgate over other toothpaste brands, when in reality, Colgate gave doctors a list of toothpaste brands and asked which ones a doctor would be okay with a patient using. Very different to how they presented the statistic, even though they did not really lie. So always be careful to know how the data was collected. Finally, our last example is the most complicated and is conditional probabilities. Here, our first example is the Sally Clark court case. A mother was jailed after two of her infants died to mysterious causes. No evidence was ever produced to suggest it was intentional, other than the chance an infant would die with no reason was super small, and the chance two would die for no reason was almost zero. So Sally was convicted and sentenced to jail. Later, statisticians showed how when accounting for conditional probabilities, the chances were actually very small that she would randomly kill her kids and that she had been wrongfully convicted. So misunderstanding these kinds of statistics can have very real consequences. To better understand this, let us work through an easier example. A test for breast cancer is 90% accurate, with a 10% false positive rate. Research shows that approximately 0.8% of women have breast cancer. So if a woman took the breast cancer test and came back positive, what are the chances she has breast cancer? The answer, about 7.4%. To understand why this is, we must use conditional probabilities. So in this example, let's pretend we randomly tested 1,000 individuals. Our research tells us 0.8% of women have breast cancer, so approximately 8 of the 1,000 women actually have breast cancer. The test for breast cancer will detect the 8 who actually have breast cancer, along with the false positive rate of 10%, which would end up being around 100 women of the 1,000. So 108 women are positive for breast cancer, but only 8 actually have it. So if a woman at random took a breast cancer test and came back positive, she would only have a 7.4% chance of actually having breast cancer. This is a very simplified version of conditional probabilities, but understanding that conditional probabilities may be at play when reading a statistic means you should be careful that whoever created the statistic has no reason to mislead you and is competent in statistics enough to account for conditional probabilities. Thank you for watching, and be careful for conditional probabilities.